How do some dressings optimise the level of excess matrix metalloproteases and others do not?
That's a very interesting and very relevant, clinically relevant question. And it boils down to the composition of these dressings and what they're supposed to be doing. If you imagine again that you have excessive matrix metalloproteases as a clinical problem, then you're speaking about wounds that have lots of exudation. And at that stage, in the chronic wounds, matrix metalloproteases are highly upregulated. So you have to do something about it. And there are two ways how you can do this. Matrix metalloproteases can be bound and locked by a dressing, so they have no chance to diffuse back to the wound bed. And by this, you're decreasing the concentration of matrix metalloproteases in the wound space. And the other thing that you can do is you can take out the cofactor that these proteases really need, and that is the metal ions. That's calcium, magnesium, and zinc. And if you trap those ions, then these matrix metalloproteases are enzymatically inactive. So you're destroying their activity in a reversible way, just on two levels, locking and decreasing the concentration of the cofactor that is required for these metalloproteases. And you can do this by the composition of the dressings. And among all these polymers that are available in dressings, superabsorbent polymers are the most suitable to do this because they have a very, very high charge density, so they are binding proteins with a very efficient way. And of course, they have an extremely high avidity to bind calcium, magnesium, and zinc, and thereby decreasing the concentration of the cofactors for these metalloproteases. This sounds very, very technical and very, very biochemical, but the take-home message is that these superabsorbent polymers, that they are really binding the proteases and make sure that they lose their enzymatic activity and don't do any harm inside the wound bed.